Now we are going to do some applications of section formula. What is the use of section formula? The first use is it can give easily the coordinate of midpoints of any line segment. The first application is coordinates of midpoint. How can we find very easily by using the section formula the midpoint of a line segment? If P is the midpoint of line segment AB, then AP is equal to PB. That is AP over PB is equal to 1. That gives lambda. That is lambda is equal to 1. Therefore, substitute lambda is equal to 1 in section formula as we done in previous lecture. We will get coordinate of point P, which is the midpoint, that is vector R, which is equal to xyz, which is equal to lambda times x2, that is A divided from the side A if we suppose, then becomes lambda times x2, that is 1 times x2 plus x1 over lambda plus 1, that is 1 plus 2. Similarly, 1 times y2 plus y1 plus y1 over 1 plus 2, comma 1 times z2 plus z1 over 1 plus 2. That is the case when it is from the side A. Or from the side B if we suppose, then it is same. Lambda times 1 times x1, that is the same because P is the midpoint. That is, it is not divided. So we take any formula, that is from A side or from B side. So we get coordinate of P, that is R is equal to xyz is equal to x1 plus x2 over 2, y1 plus y2 over 2, z1 plus z2 over 2. That is, if a point divide the line segment, any line segment in the ratio 1:1, or say it is a midpoint of that, then we get the coordinate of that midpoint by adding each component and then divided by 2. So that gives the component of midpoint of any line segment. Therefore, these are the midpoint of line segment AB. So this is the important application of section formula. Now the next application of section formula is centroid of a triangle. What is the definition of centroid? Centroid is the meeting point of all the medians from the three vertices. That is, and that point divides the median in the ratio 2:1. That point is called centroid of the triangle. So we have to find the centroid of a triangle by using section formula. Let ABC be a triangle in R cube space. Pose position vector of A, B and C are vector R1 with component x1, y1 and z1, vector R2 with component x2, y2, z2 and vector R3 with component x3, y3, z3 respectively. That is, we are going to draw the triangle. That is A, B, C. Let D be the midpoint of BC. So by the first application of section formula, coordinate of or position vector of dr, that is here it is with position vector r2 and this with position vector r3. So the position vector of dr, by taking the sum of these two position vectors, that is r2 plus r3 over 2. This is a rule to get the coordinate of midpoint. Let its name be r4. So coordinate of dr r4. See. Now let G be the point on AD, as A is a line segment from the vertex A to opposite side. We divide the opposite side in the same ratio, that is D is the midpoint of this, then AD is called median, and if we take any point on the median, that divide the median into 2:1 ratio. Therefore, let G be the point which divides AD in the ratio 2:1. From the side A, that is AG over GD is equal to 2:1 is equal to M over N. Therefore, the position vector GR, that is by section formula M times R4 plus N times R1 over M plus N in the ratio vector R4 and R1. Now substitute the value of R4 and R1. So it becomes 1 over M plus N. R4 is vector R2 plus vector R3 over, that is, now substitute the value of m and n and vector r4. We get m is 2, vector r4 is vector r2 plus r3 over 2 plus n is 1 into r1 over m plus n, that is 2 plus 1. So we get 2 and 2 is cancelled out here and we get vector r2 plus vector r3 plus vector r1 over 3. Now substitute the component r1, r2, r3. We get x component as x1 plus y1 plus z1 over 3, x2 component plus y2 component plus z2 component over 3 plus x3 component, y3 component plus z3 component over 3. That are the coordinate of vector G with component x, y and z, where x is x1 plus y1 plus z1 over 3, y is x2 plus y2 plus z2 over 3, and z is x3 plus y3 plus z3 over 3. That is, there is a symmetry of x1, y1, z1 coordinates. Since there is symmetry, in the coordinates of G and G is a point which lie on the medians, that is, intersection point of three medians. Therefore, G is called centroid of the triangle whose coordinates are that is x1 plus y1 plus z1 over 3, x2 plus y2 plus z2 over 3, x3 plus y3 plus z3 over 3. So it was all about the second application of section formula.